Homework out. The book's open to page 95. You did 1 through 19, the odd. They're on page 95, practicing with a new type of equation that we've worked on just these past couple of days, Audrey, called quadratic equations. Good. And what is it that makes a quadratic equation quadratic, Kendall?
Like an x squared.
Good, the x squared. And because of the x squared, quadratics are going to have how many answers, Michael? Two. And we said there's really two types of quadratics. We've got obviously quadratics that have the x squared, but then may also have an x to the first, Brandon. Complete. And if they don't have the x to the first, Abby, we would call them pure or incomplete. We started by looking at the incomplete quadratics because they're the easiest. And really there's just two steps to solving incomplete quadratics. Maddie? Or isolate it and then take the square root. When we take the square root, Genesis, it's important to remember once we take the square root to put what to make sure we have two answers instead of one. Okay, so we've got our incomplete quadratic, right? We've got the x squared isolate. We take the square root of both sides, but when we take a square root, we've got to put what in front of our answer? Positive, negative. Because otherwise we have one answer. The positive, negative shows the two answers there. And then yesterday we began looking at complete quadratic equations with the x to the first. And I said there's going to be a few different ways we can solve these, Kendall, but the method that is normally first choice, normally easiest, is the factoring method, where we want to set the equation class equal to 0, and then, as the name of the method suggests, we factor. That's what we were doing on number 1 there in your homework. We have the x squared negative x negative 42 already set equal to 0 for us. From here, we just need to factor. And how do you factor that quadratic trinomial, Audrey?
X plus x plus minus 7.
There we go. So the outer inner gives you the negative 1x. And then I said we're going to take each of those factors and set each one of them equal to 0. Because, again, if two things are multiplied and together they equal 0, one of them at least must equal 0. And that'll give us what? Two answers for x. Back to Audrey.
Negative 6 and 7.
Negative 6 and 7. How many had those answers on number 1 questions? Looking at number 2, again, it's already set equal to 0. All we had to do was factor, though this time the factoring may be not quite as easy. We, of course, get y and y. We know negative and negative. How did you split up a 120 to give you a 29? Abby?
5 and 24.
End up with 5 and 24. There's a lot of ways to split up the 120. Maybe the easiest would be 10 and 12, but that doesn't give you a 29. Maybe, I don't know, a 2 and a 60. Well, that doesn't even come close to giving you a 29. Neither does 4 and 30. It is divisible by 8, right? 8 and 15. That's closer to 29, I guess. But end up good with the 5 and the 24. And just take some stick-to-itiveness. Again, you've got a calculator you can use to kind of help you factoring it up. And then, when we set each of these to 0, what two answers do we get, Abby?
5 and 24.
Positive 5 and positive 24. How many had those two answers? How many couldn't figure out how to factor the 120? All right, good. You stuck with it. Excellent. Looking at number 5, this one's a little obnoxious because it's not equal to 0 yet. We need to get it equal to 0. And I said when we've set it equal to 0, doesn't really matter left or right where the 0's at, as long as, Michael,
the x is positive.
The x squared is positive. And it ain't. So since it ain't positive, let's move it. And let's make this side of 0 equal to
X squared negative 6x positive 112.
All right, this moved over. It changes sign. This moves over. That didn't move, so negative 112. And I mean, this is going to be a joy to factor. Of course, x and x, positive, negative, and then 1 and 112 is stupid, right? If 2 goes in, what is that, 56? 3 does not go in, 4 will go in. What is that, 28? We're still nowhere near 6. 5 go in, 6, no, 7, 8 maybe? 8 and 14, there it is, all right. Just kind of work your way through the progression. You use the calculator as needed. We wanted the 14 to be negative, the 8 to be positive, so we end up with what, two answers? When we set each of those equal to 0?
Negative 8 and 14.
Negative 8 and positive 14 are answers. How many stuck with it? Figured it out, got those answers. All right, questions from those who did not? Questions? Puzzled look on Abby's face.
Oh, I had positive 112, but I still ended up with those answers.
Did you bring the 112 over here
Yes.
as a positive?
And then multiplied by.
And then you multiplied everything through by a negative to
Except
make it.
Except I forgot to change that one because I did it at the same time. So it changed to a positive. But I still got those answers.
All right, so you made 2 wrongs, and it worked out well for you. Unless I noticed it on a quiz or test, and then you would still lose points. But if I wasn't paying attention, which has been known to happen, and I just noticed, oh, right answers, of course you did everything perfect because she's Abby. And then, you get away with it. And but I might not. You just never know. The Holy Spirit of God may move and say, no, stop. Look at that paper again. That's not right. Minus 54. I don't know. All right, questions on this. Questions on this, because she's happy. All right, looking at the next one, we have 15y squared, positive 12 equal to negative 36y. Genesis, what do we need to do here?
Isolate.
Well, if it were an incomplete, we would isolate. Is it incomplete, though? No, I've got the squared and the first. So incomplete, isolate the y squared. Complete quadratics, set equal to 0. So
Pull the negative 36 over. 15y squared. Negative 30, positive 36y. Positive 12 equals 0.
and the next step is to factor completely. And what should be the first thing we do in this factoring?
Pull out a common factor.
Pull out the common factor of
3.
3. That's going to make the factoring easier because it's going to give us little numbers, which I love, little numbers.
5y squared.
Kendall's beaming. All right, you're not a number, you're a name, not a number. All right.
Positive 12y plus 4.
And then from here, again, we're going to keep the 3, don't lose the 3. Factor it up, 5y squared, of course.
1 not 5y.
Both signs.
Positive.
And probably for the 4,
1 and 4.
outer inner.
No.
9, so no, okay, so not 1 and 4.
4 and 1.
I'm sorry, 4 and 1. All right, outer inner. It's 21, okay, so that means it's got to be
2 and 2.
2 and 2, unless we screwed something else up, all right? Outer inner.
Yes.
Oh, there it is, okay, good. And then watch, class, how many factors do I have? 3 of them. And I'm going to set each of them equal to 0. But one of them is a lie. 3 equals 0. Of course 3 doesn't equal 0. That's okay. We got the other 2. And so here y is going to equal Genesis.
2.
When it moves over, it becomes a
Oh, negative 2.
negative 2. And then here, I'm going to start by moving that over to get 5y equals negative 2, but I still have to also divide the 5.
Negative 2 fifths.
Negative 2 fifths. And these should have been our answers here. How many have these answers? All right, so strategy tip. I just wanted to show this and then allow you to cheat and take some shortcuts. Technically, this is what we do. But if you factor out a common number, there's no way 3 is ever going to equal 0 anyway, right? So once we factor it out, if it's just a number, cross it out. Now, if you factor out a common letter, could a letter equal 0? Sure, but a number never will, so you could cross it off. Or, think of it this way, divide everything by 3. And then you get that anyway. And to me, that's the even better way. So as opposed to factor out the 3, which factoring is division, just divide everything by 3 if you see a common factor. And I think that'll be a quicker way to get rid of stuff. Yes, sir?
So I did the entire problem without taking out the 3 and the 7.
Bless your heart. It will work, right.
Would you
just
take
have
out points though?
No, it's not wrong. It's just you have to deal with bigger numbers and I'm lazy. But no, no points off. Nothing wrong with that. Again, you're now splitting this into what, a 3y plus 6, 5y plus 2? Or y plus 2 and 15y plus 6?
That was 5y plus 2 and 3y plus 6.
Yeah, so no, nothing wrong with that at all. Same answers, but it's just little numbers, and I love little numbers. We love Kendall too. All right, questions on this? Questions on this? All right, let's take a look at number 9. We've got a 2q squared is equal to negative 15q, negative 22. And Brandon.
Move the negative 15q, negative 22 is positive.
All right. All equal to 0. And then what?
Backwards row to get 2q plus 11 times q plus 2.
And yep, that runner looks great. We set them both equal to 0. We end up with what? 2 answers for q.
Negative 2 and negative 11 and 2.
And there we go. How many got those answers for number 9? Questions on that one? Any questions on complete quadratics by factoring? We will practice a little bit more in a moment, but any questions for now over these? All right, let's move on down now to numbers 11 through 19, the odd. And these were, for the most part, incomplete quadratics. And again, the key to the incomplete quadratic class is to isolate the x squared. Let's try that again. Class, the key to solving incomplete quadratics is to
Isolate the x squared.
good. And then, of course, once we got it isolated, it's as easy as just taking the square root of both sides. So on number 11, if I want to isolate the x squared, well, actually, first of all, look at that number 11 class. Everything's negative, right? What could I do?
Change it to positive.
Make everything positive. So my first step is, I really just hate negatives. So, boom, there's my problem now. All right, so now I need to subtract the 11 to get 441. And then I need to divide away the 9. And fortunately, we have a calculator for that. We get
49.
and then I take the,
Square root.
to get x is equal to.
Positive negative 7.
Questions on that? How many had that? Ooh, questions.
I just did it a different way.
Did you get the same answer?
Oh yeah. Yeah.
Okay.
Whole lot more work though.
All right, all right.
I got it squared over normal number. I don't know.
Does it make sense what we should have did? And again, you don't have to knock out the negatives, but negatives just really make my life miserable. So anytime I can get rid of them, by all means. Number 13. We're going to subtract away the 13 to initially get anyone 252. Then divide that by 7 on the calculator, I hope. 36. Oh, and then take the square root. I don't even have to write on the chalkboard. I am not lazy. Positive negative 6. This is great. Number 5. We subtract away the 12. 17. Did I say 5? Number 15. We subtract away the 12 to get 17. Divide by, oh. Well, we can't divide by 4. We just have to leave 17 fourths. And then we take the square root of both sides. Of course, don't forget the positive, negative. But I can't leave it like that. So what do we have to do, Abby?
You can take the square root of 4.
To get?
Positive, negative, square root of 17 over 2.
Get a positive square root of 17 over 2. And we need to leave the answer with the rationalized denominator. Hey, at least it was a 4. Right? That worked out nicely for us, at least. For this, we can plug it into the calculator. How many did? All right, pull your calculators out now and do it. Square root of 17 divided by 2. You're going to want to take the square root of 17 first, then divide by 2.
2.061.
All right, and then so 2 decimal places, like they said, hundredths place 2.061 becomes 2.06, and positive, negative that. Okay. How many got the 2.061, blah, blah, blah on the calculator? Anyone not get that on your calculator? Say, ooh, how do I enter this again? I want to make sure you're able to do that. Any questions how to enter the square roots onto the calculator? All right. Number 17. It's not all negatives, but there's a lot of negatives. So once again, 17, what could I do, Michael?
You can, I don't know, because I did it in my head. So.
On number 17?
Yeah.
What could I do?
We're on page 95.
Yeah, because there's a bunch of negatives. What could I do?
You can do positive.
Change all the signs. So what does my equation become?
You get positive 13y squared, negative 5, equals positive 1,048.
48, you said. Okay. Thought I heard a 30. Yes, that doesn't sound right. There we go. And then we add the 5 now, class, to get 1,053. Then we divide by the 13 to get, please come out evenly.
81.
And we take the square root to get positive negative 9. How many have that answer on number 17? Again, do you have to take out the negative first? No. But I feel like it makes your life a lot easier. Questions on number 17? And then number 19. Is that incomplete, class? No, it's complete. But we can treat it like an incomplete because, Audrey, I can rewrite that r squared plus 4r plus 4, that perfect square trinomial, as a binomial squared, specifically
R plus 2.
squared is equal to 11. And then from here,
You take the square root. Okay, R plus 2 equals the square root of
well, minus a point so far.
positive, negative,
There we go. And then to finish it out, just.
subtract the 2.
And I can't subtract it, like actually subtract, so I'm just going to leave it as a separate term. And there are my answers at your seats. Take the square root of 11, then subtract 2.
3.32.
Did you subtract 2?
Oh,
1.32, okay. And then take the negative square root of 11. Now again, you can't type in the negative 11 and hit the square root. It's got to be square root of 11, then change it to a negative, then subtract 2 to get
Negative 5.32.
negative 5.32. And there's our approximate answers, our actual answers, positive, negative square root of 11, minus 2. Anyone perfect? 10 for 10 on the homework. Couple of you, a few of you. Okay, 9 out of 10, just missed 1. 8 out of 10, just missed a couple. All right, do we understand the 1 or 2 that we missed? Any questions at all on this homework? All right, turn the page, page 96. And let's take a look at word problem 46. And read the word problem for us, if you would, Genesis.
The first number is 6 less than 3 times the second number. The product of the first number and 5 less than the second number is 120. What are the numbers?
All right, so how many unknowns, class? 2. And it describes these numbers as being a first number and a second number. So first number, second number. How many perfect so far? How many already wrong? All right, which one gets to be x, Genesis?
The first one? No, the second.
Second one, because our very first sentence tells us, comparing them, that the first number is 6 less than 3 times the second number. So my second number gets to be x. How would I represent the first number? 3x minus 6. And then it says that the product, what does product mean, class? Multiplication. The product of the first number and not the second number. It's not the product of the first and second. The product of the first and 5 less than the second is 120. Volunteer for the equation. Brandon?
3x minus 6 times x minus 5 equals 120.
Perfect. Anyone else get the same thing, just not as brave as Brandon, to raise your hand? Okay, a few of you. Do you see it? The first number is 6 less than 3 times the second number. There's your x, there's your 3x minus 6. The product, we're going to multiply, of the first number, 3x minus 6, and 5 less than the second number, x minus 5, is 120. Well, solving an equation, what do I got to do here? Back to Genesis. Get rid of parentheses first, right? And how will I get rid of those parentheses? 2 binomials. They're being multiplied. FOIL, there we go. So we multiply our first. The outer inner ends up giving us... Is that what you said? Negative 21x?
I was working it out.
Oh, you're working it out. Sorry. I heard a mumbling and wasn't quite sure what you said. Negative 15x, negative 6x, negative 21x, and the last?
Positive.
All equal to 120. And suddenly, class, for the first time in a word problem this year, we have a quadratic. Which means we're going to end up with a couple possible sets of answers here. That's okay. Well, let's roll with what we got here. How many got a quadratic like this? You're still on the right track. Maddie, wheels fell off the wagon? All right. Then let's pick it up with Maddie. What should we do now, since it is a complete quadratic? You could divide everything by 3 to make numbers smaller. I like that. Let's do it. That looks so much nicer and cleaner and easier. But now that we've done that, now what do I need to do? By bringing over the as a to get There we go. And now that it's at equal to 0 class, we should factor in general, right? Backwards FOIL in this case to get x and x. Science class, positive negative to 30. 10 and 3, we want the 3 to be the positive and the 10 to be the negative. So what two answers for x?
Negative 3 and 10.
Negative 3 and 10. Now, students who had geometry last year will recall that sometimes when we work a quadratic, the negative answer makes no sense. For instance, if we were talking about a certain amount of money, I guess you could say negative $3 is debt, but like negative 3? Or if we were talking about a certain number of people, negative 3? Or if we were talking about the measures of a room or something, negative 3, we would ignore it. But these are just numbers. So the second number is either negative 3 or it is 10. Does that make sense? It's a couple different possibilities. If it is negative 3, then what's the first number, class?
Negative 15.
But if it's a 10, then what's the first number? 24. So either the two numbers are these two, or they are these two. And if we were to check, obviously we know that the first number is 6 less than 3 times the second. We've already checked that part. It says the product should be under 20 if I take 5 less than this. What is 5 less than this?
Negative 8.
Negative 8. Is the product of negative 8 and negative 15 120? Yeah. What's 5 less than this? 5. What's 5 times 24? 120. Both of them check out. So 2 sets of answers. Did anyone get this? All right, good. This was really the first time we've seen this. If you didn't get it, don't be upset or beat yourself up. But do you see the way word problems are going to begin to go now that we know quadratics? You may have multiple sets of answers, and unless there's a good reason to ignore a set, for instance, negatives wouldn't possibly apply, we got to roll with it. Questions on this? Let's look at some more word problems together then. And you can go ahead and set your books aside for just a moment. Focus just on the first problem for now and read that for us if you would. Let's see here. Michael.
A rectangular board having a perimeter of 46 feet is 5 feet longer than it is wide. Find its dimensions.
All right. How many unknowns in the problem, Michael?
2.
What are they?
The length and the width.
Right, when it says find its dimensions, that's talking about the length and the width. It says longer and wide, but it's talking about length and width. So I'm going to do L and W here. And which one gets to be X, Michael?
W.
Right, it says that the board is 5 feet longer than it is wide, so we'll let the width be X and the length would simply be?
It would be X plus 5.
Good, 5 feet longer, X plus 5, not 5 times as long, so not 5X. And then the number we haven't used yet is the 46. Well, it says the 46 feet is the board's
Length, no, it's perimeter.
perimeter. Now, what does perimeter mean, especially those who are in geometry already?
The outer edge.
Outer edge, the distance around, right? The sum of all the sides. Well, on a rectangular board, how many sides are there?
4.
4. 2 of them are called the length, and 2 of them are called the width. So if I know that not length plus width equals perimeter, but 2 lengths and 2 widths equals perimeter, right? So how would I represent 2 lengths, class? 2x plus 10, or 2 times the quantity x plus 5, but this is quicker. How would I represent 2 widths, of course? 2x. And the perimeter, it says, is 46 feet. Questions on this? Make sense? Using something you know, not length plus width equals perimeter. That's right, yeah, I said it wasn't, and then I'm like, why did I leave that up? I meant to cross that out. That's not true. It's double lengths and double widths equals perimeter. So you plug in the numbers, we combine like terms, class. 4x, we subtract away the 10 to get 36. We divide out the 4 to get x is 9. And that means apparently the width of this board is 9 feet. Which means the length must be 14 feet. This is a really big board. All right, so 9 foot by 14 foot board. That's almost like the size of the floor of some small bedrooms. Anyway, questions on this? Questions on this? So look at the next one and read that one for us if you would. Maddie, if you can be nice and loud, fake it. Project. So they can hear you on the camera.
The area of a sheet of cardboard is
one day you're going to be a mom, and your kid's going to do something, you're going to holler at that kid, and you'll be like, Wilbur, you get down here right now. What'd you say, Mom? I couldn't hear you. Anyway, all right, so once again, it says find the dimensions. Once again, Maddie, we know by dimensions it's referring to length and width. And which one gets to be x, class? The width again. Not because it's always x, it just happens to be defined in terms of x there. And then what about the length, Maddie? 1 1/3 times x. Because I don't do mixed numbers. I hate mixed numbers. So, let's do 4/3 x, or 4x over 3. I think I like that better. And then it says the other number we haven't used yet, Maddie, is the 48. And that's the area. All right? Some of you had geometry last year. Some of you harking back to your pre-algebra days. How do I find the area of a sheet of cardboard that is presumably rectangular, since it mentions a length and a width, class? Length times width. We know that length times width is going to equal area. So we plug it in. In for the length, class? 4/3 x, so 4x over 3. In for the width, we plug in x. And the area is 48. And we solve from there. We multiply like it says to. 4/3 x times x. 4x squared over 3 equals 48. And guess what we've got again? Another quadratic. But what kind of quadratic do we have, class? Pure quadratic. Incomplete quadratic. Because I have the x squared but no x to the first. And when you have an incomplete quadratic, class, you need to isolate the x squared. What would I do here, Maddie, to isolate the x squared? Okay, good. We can multiply the 3 to knock the fraction out. That would give me a 4x squared is equal to, someone with a calculator?
44.
Or someone with a really fast brain. And then to finish getting the x squared by itself, obviously, Maddie, divide away to get x squared is equal to
36.
All right, Maddie's voice just got deeper. And then, Maddie, that means that x is going to be equal to positive negative 6. All right, that means that the width, x, of this board is either 6 inches or negative 6 inches. Thoughts? Can a sheet of cardboard have negative 6-inch width? No. So here, because the negative option is nonsensical, we will ignore it. Make sense? So when we take 4/3, we will only take 4/3 of 6, which is 8. And apparently this is a 6-inch by 8-inch piece of cardboard. Questions on this? Any questions on this one? There it is. All right. Let's take a look at the next word problem. Read this one for us, if you would. Kendall.
When 5 is added to a certain number and also taken from it, the product of these results is 75. Find the number.
How many unknowns in the problem, Kendall?
1.
1. And it's just
The number.
the number. And class, if you only have one unknown in a word problem, it automatically gets to be x. And the entire problem just becomes
An equation.
algebraic representation. So we're literally going to take, people upstairs are obviously walking very heavy, and the entire screen is shaking. All right. Quiet up there. All right. So, Kendall, let's represent. It says when 5 is added to a certain number. Well, if our certain number is x, how would I show that?
X plus 5.
X plus 5. The rest of you are doing this with us as well. And then it says, and also taken from it, it being the certain number. How would we show 5 being taken from a certain number? So we said if 5 is added to a certain number, okay, that's x plus 5, and also, meaning 5 is also taken from it, meaning the number. How would we show 5 taken from a certain number? X minus 5. So we've got an x plus 5, we also have an x minus 5, and it says that the product. Well, how would I show the product of these two things?
Multiply.
Yeah, multiply, just run them up against each other. All right, it says the product of these results
Is 75.
is 75. And there we go. Algebraic representation makes our equation. What are we going to have to do to solve here, Kendall?
That's a sum and difference.
Right, we could FOIL, but I like that she spotted the sum and difference, so we're going to do three things.
Square the first square, let's put a minus sign.
Good, square the first square, let's put a minus sign to get.
X squared minus 25.
All equal to 75, then from here, Kendall,
Add 25.
to get.
100.
And this incomplete quadratic, where they're going to take the square root to get
10.
minus a point.
Also negative 10.
Right, it's either positive 10 or it's negative 10. Either of those numbers would be our answer here. And again, it's just a number. Numbers can be negative. How many have positive or negative 10 as your two answers? Questions on that one? We've also done a lot with fractions here of late, so we can do word problems that involve fractions as well. Go ahead and read this last word problem for us. Audrey.
The value of a fraction is 3/8 and its denominator is 15 greater than its numerator. Find the fraction.
How many unknowns do we have in the problem, Audrey?
Not 2.
2. It sounds like there could be 3, or maybe it sounds like it could be 1. At the end, it just says find the fraction, which makes it sound like there's one thing I'm finding. But as you're reading it, it talks about a denominator, it talks about a numerator, then it talks about a fraction, so some people could argue 3. Audrey recognizes that if we find the
Fraction. Denominator.
and
Numerator.
then we will have found the fraction. For instance, if I said, I'm going to try to teach you how to read minds. You ready for this, Maddie? It's revolutionary stuff here, okay? It's going to change your life. All right, I am thinking of a fraction. The numerator is a 4. The denominator is a 13. What's the fraction? Class? Brandon is a mind reader, 4/13. Because you understand, if you know a numerator and a denominator, you know fraction. So it's not that denominator, numerator, and fraction are 3 unknowns. Fraction comes when you know numerator, denominator. So I just write 2 unknowns, and of course they are numerator and denominator. Which one of these gets to be x, Audrey? The numerator, because it says that the denominator is 15 greater than its numerator. Comes back to numerator. How would I represent the denominator?
3/8
X plus 15. All right, class. I am thinking of a fraction. The numerator is x. The denominator, x plus 15. What's the fraction? He's still a mind reader. X over x plus 15. Now, I'm goofy about it because some students can literally write this and they're like, I don't know how to make the fraction. Are you kidding me? You know the numerator, you can't make the fraction out of that, okay? That's the fraction right there, x over x plus 15. Now, what does it tell me about this particular fraction that has been described, Audrey? The value is or equals 3/8. So this thing, the value of that is or equals 3/8. And suddenly now, class, I have a proportion. How do we solve proportions?
Means equals. Oh, means equals.
What?
The product of the means equals the product of the string.
Or in 2 short words or 1 hyphenated word?
Makes sense.
Cross multiply. There we go. Because the product of the means equals, but you know, you're correct, right? The product of the means equals the product of the exchange. Therefore, we cross multiply. So back to Audrey. The product of the means. Oh, that's the extremes.
3x plus 45.
And then the product of the extremes. Good news is on quiz or test, doesn't matter which order you do them, as long as you set them equal to each other. Then, Audrey, 2 quick steps.
You bring it over to get 5x. Plus 45, x equals 5, 9.
I knew you meant 9. All right, so what's the numerator, class? 9. What's the denominator, class? 24. All right, here we go. Find the fraction, right? I'm thinking of a fraction. The numerator is 9. The The denominator is 24. What's the fraction?
3.
No!
9/20.
9/24.
Technically,
No, 9/24. The value of the fraction is 3/8. But the denominator is supposed to be 15 greater than the numerator. 3/8 don't cut it, so don't reduce. 9/24 is our answer. Does that make sense? All right? Because if you reduce it, you're basically just going right back to what it already said. The value of fraction is 3/8. Find the fraction. 3/8. That's not what they were going for. They were going for something that was equal to 3/8, yet had a numerator of 15 greater than the denominator. Does it make sense now? All right? Questions on this?
I understood. I thought you wanted us to reduce though.
No. Because if we reduce, we've just undone the point of the work.
That was the point of the work.
We didn't want to reduce. We wanted a fraction that was equal to 3/8
And just multiply by 3.
if you knew to do that. But there's a lot of fractions equal to 3/8. You would want one where the denominator is 15 greater than the numerator. And I want to see the equation. Can you represent it? Because we'll do ones that are maybe more challenging moving forward. Questions on this? We got it now?
Yes.
All right, let's go ahead and do some classwork here real quick. Turn back to page 95 if you're not already there. Turn back to page 95 if you're not already there. And do numbers 2 through 10 the even. 2 through 10 the even. Abby is not the mind reader. Brandon is, evidently. That's okay. We'll work on those mind reading skills moving forward. When you finally master it, you can go home and say, guess what? I can read minds now. Your parents will be very disturbed. All right. I was going to say impressed, but no, that's not true either. Mom will look at you and say, all right, read my mind. Clean up my room. You are a mind reader. And your mom will be very impressed then. Take out the trash? Yup, that too. Can I stop reading your mind now? So in general, mind reading sounds pretty awful, doesn't it? Like, if you could actually see what people were thinking about you, wouldn't that be a depressing life?
You know who your friends were.
It's true, but you might find out you have very few. Set it equal to 0. Factor. Set the factors to 0. And solve. All right, for sake of time, pencils down. For sake of time, look this way, pencils down. First one's not too bad. You might be thinking 4 and 7, but the signs happen to be different. You need a 12, 14, and 2. It's not too hard to come up with. 7 to 0, move 14 and negative 2 over to get negative 14 and positive 2. How many had that for number 2? Number 4, this was annoying because I'm looking at the 1 and 5 and I'm like, well, 5 and 21. Well, 2 doesn't go in, 3 goes in, 35, that's not even close. 6 won't go in, 7, I have no idea. Well, let me try it. Yeah, 7 times 15. Hey, that works. So definitely not something we've memorized, but there it goes. Move them both over as positives, get positive 7, positive 15. How many also? Figured that out despite the annoyance of the factoring. Next one, a little bit more straightforward. Once you get it equal to 0, move both of these over so the x squared is positive, or change all the signs, then you can bring the 63 over. Again, 63, I always think 7 times 9 anyway. That gives you the 16. That's great. Move them both over as positives. Positive 7, positive 9. Outstanding. The next one, brought the 34q over as a positive. I'm like, well, this is going to be lovely. The only thing I could think right off was 5 and 7q. Signs had to be different. I'm like 3 and 7, but I knew I couldn't put a 7 with the 7. So I'm like, well, let's try 7 and 3 and see what happens. Happened to work on the first try. 2 steps. Subtract the 7, then divide the 5. Negative 7/5. Add the 3, then divide the 7. Positive 3/7. How many had that for number 8? Questions. Sometimes you get lucky on the first try. Doesn't always happen. Then on the next one, move both of these over as negatives. Again, backwards FOIL. I was like, well, maybe 6 and 1q. I'm going to start with 3w, 2w. Signs have to be different. I know I can't put a 2 with a 2, so I'm going to put a 2 here, 7 here, see if that works. Again, happen to get lucky on the first try. They both checked out. And so add, subtract the 2, divide by 3, negative 2/3. Add the 7, divide by 2, positive 7/2. How many had that for the last one? Number 10. Those who made it that far. All right, questions on any of these? Questions on any of these? I want to introduce something to you very quickly that we're going to look at more tomorrow. And let me revisit this thing here, this x squared negative 22x plus 105. This is really obnoxious with the factoring. There is another method that we're going to talk about tomorrow. So you're not writing anything in your notes, just kind of watching. The method tomorrow basically says, let's kick out the constant to the other side and leave a little bit of a gap. Obviously that means the positive 105 would become a negative 105. And in the gap, we're going to force this to become a perfect square trinomial. Because remember, if you have a PST, you can make binomial squared. You can treat it like an incomplete quadratic, remember? So the question is, what goes in the blank? Well, remember for a binomial, when you square it, you square the first, square the last, then you multiply and double, right? So this would have had to be an x, And apparently I multiplied something and doubled to get a negative 22. Well, what do you double to get a negative 22? Negative 11. This apparently is a negative 11. So what would we get then if we squared the last? A positive 121. But I can't just randomly stick a positive 121 on one side. I'd also have to balance it by also putting a positive 121 on the other. Does that make sense? Now this becomes the binomial squared I already knew I wanted. This I combined to get anybody? 16. And now we're back to what we did before. Take the square root, x negative 11 equals take the square root, positive negative 4, good Brandon. And then we add the 11 to the other side, and there's the same two answers. 4 plus 11.
15.
Negative 4 plus 11. 7. And once we figured out the 121, it was a lot quicker, I think, than slaving through the factoring. There will also be times when you literally can't factor. Then you're going to have to go with this method. We're going to look at that more tomorrow. Now, homework this evening. Have a wonderful rest of your day. And when the bell rings, you'll be dismissed.